Oh, my computer something wrong. Sorry, give me a while. Can you hear me?
Yes.
Oh, can ah? Okay, okay, okay. So I got two iPads, so the two iPads is me. Yeah.
Recording in progress.
Okay, can, cool. Okay, question 9. Okay, so let's start with question 9. So this is a revision
Only
package.
part one. Only part one. Yeah.
Oh, okay, so it's all good. Okay, basically the gradient, right? Okay, the y-intercept would be the price, right? Okay, because y, right? This is the number sold. This is the number that is sold. Y, this is the number that is sold. So if you see, okay, basically if I draw this graph out, right? The graph will go something like this one. This would be like 1380. This would be Y. This would be X. So, okay, if you look at 1380, this is the y-intercept. The y-intercept basically means that if uh this is basically when x equals to 0. Do you agree? So for example, if I take y equals to negative 80x plus 1380, right? 1380 is the value of y when x equals to 0. This means that what does y means, right? Y will refer to the number of balloons that I will sell if I give away for free. Because x equals to 0 basically means that it's free. It means that your selling price is free. That means I'm not selling anything. My balloon is giving away for free. So far, okay? Because when x equals to 0, x equals to 0 literally means the y-intercept. When x equals to 0, what does y become? Y will become 1380. It means that if my x is 0, right, I'm going to so-called give away or sell away 1380 balloons. That's what I mean. It can also mean that I have prepared 1380 balloons to start with. That's what the student council prepared. Is that okay, Suji?
Yes. What about the gradient?
What about the gradient? Okay, so gradient, you think of it this way. Okay, if for every so gradient, right, is like okay, it will increase. So you notice if I increase x equals to 1, x equals to 2, so on and so forth. For every so-called increase in 1 unit, right? For every $1 increase in x, then there are 80 lesser people who will buy the balloon, who will buy the balloon. There are 80 lesser people who will buy the balloon. So-called maybe uh, they never bring enough money. Okay, also in economy, we say that this is called they are being priced out. Like this is out of their barrier. So every X value, right? For every 1 unit that I increase the X value by, I'm going to lose 80 customers. I'm going to lose 80 customers. I'm going to lose 80 people who will not buy the balloon. Until I increase until I'm somewhere here. Basically, nobody will buy the balloon already. So Y basically stands for the number of people who will buy the balloon or the number of balloons that I will sell. Mm. Does that sound okay with you?
Yes.
Okay, hold on. Okay. So that is part one. Any any other question?
I think so. I had trouble doing question 4 for topic 7.
Topic question. Okay, okay. This is a popular question. I think a lot of people ask. Okay. Topic 7. Okay. This one. Okay.
Yes.
So this question, right? Okay, I throw two sandbags successively onto the mat. So if I have so-called let's say I throw the first bin bag, one bin bag here. Okay, let's say if I throw both inside, right? Both inside, right? This one will give me big toy. Okay, both inside one big. So I imagine I got one sandbag in the small, one sandbag here. Then I will get big toy. I will get big toy, right?
Yes.
Okay, so if I throw only one, that means I mean the other one cannot go anywhere, assuming that both cannot throw beyond the larger circle, right? One will be here, and then one will be here. Okay, so then that means, right, I will get a small toy. So here, right, what does A union B prime means? Okay, A means I win big toy, B means I win small toy. So A union B prime, right, really means that I'm going to go home. I'm going to go home empty-handed. That means I'm a loser. Yeah, I basically cannot get anything. I throw both. So how am I in this game, right, of throwing sandbags, right? How am I going to become a loser? The way I will lose, right, is if both my sandbags land in Y. Both my sandbags land in Y. Okay, so basically this 9 over 16 that you see over here, right? The 9 over 16 actually is the probability that the first land in Y and the second also land in Y. Is that okay?
Yes.
Can I? So now the question says that by draw a tree diagram to show the probabilities, right? So that's what we will do. First, I show the first one. Okay, first one, this is X, this is Y. Then I throw the second hand back, X, this is Y. So the third one, this is X, this is Y. So this is the first throw, this is the second throw. Now you can see that the way for me to become a loser, right, is if I follow this track. I follow this track where I got first Y, second Y. Okay? So the probabilities are the same because the throws are independent. The handbags are independent. So I throw, right? If I say that, first throw, first one Y, second Y, the probability is equals to 9 over 16. Can I also say that each time, right, when I want to throw a Y, right, it's actually square root of 9 over 16, which is 3 over 4. So what I'm getting here is I'm getting something like that. This is 3 over 4. This is 3 over 4. Like that. Okay, ma? 3 over 4 times 3 over 4 give you 9 over 16. This is the rock where I go home empty-handed. This is actually my A union B prime. This is my A union B prime. All those in blue points to the same thing. Okay, all those in blue points to the same thing. That is my A union B prime. Okay with you?
Yes.
Then after that, this is 1/4. If this is 3/4, if this is gonna be 3/4, then this guy gotta be 1/4. This guy gotta be 1/4. This guy gotta be 3/4. This guy gotta be 1/4. Okay or not? So that's what it looks like. So my tree diagram I show you already. It looks like that. So far, okay?
Okay.
Hmm.
Yeah.
So after you do, if you know part one, you should know how to do part two already. Uh,
Yeah.
This question I also recorded in the earlier lesson, so not to worry, you can also check. I'm also recording it here. Okay.
Mr. Tan, can you go through like AFL 5 question 2 and or
AFL 5
like
question 2.
yeah.
Yeah, so I just saw, okay, AFL 5 question 2 for polynomial onwards. AFL 5 question 2. AFL 5 question 2. AFL 5 question 2. Wait, give me 1 second. I multitask. Sorry. Okay, AFL 5 question 2. AFL 5. Okay. So this one, it says that, okay, fx is ax cubed plus ax squared plus the x squared plus bx minus 6. Okay, is exactly divisible by 2x minus 3 and leaves a remainder. Is part 1 okay with you or not okay?
It's simultaneous equation, right?
Correct, simultaneous.
Oh, okay.
You know to do, huh? Okay, so this one,
Think
right?
so.
Yeah, you sub x equals to 3 over 2, right? And f of 3 over 2 would be equals to 0. This one, you substitute x equals to 1, then f of 1 will be equals to negative 10. Actually, it's just simultaneous. Quite chill one, quite chill one. So this is the part that says, okay, then this part for remainder of negative and x minus 1.
And thank you, Mr. Tan.
Thank you. So if all goes well, okay, you find A and B, then still got part two, part three. I want to talk about part two, part three. Your A should be 6, B should be negative 11. Your A should be 6, B should be negative 11. So after that, you need to factorize, right? The nice and beautiful thing is that you know that, okay, after you got A equals to 6, 6x cubed, you know that B is negative 11, so it's negative 11x minus 6. This should be, the cubic guy should be equals to a linear guy, which is 2x minus 3, very nicely, right? Multiplied by some quadratic guy, which is, I'm just going to call capital A, capital B, capital C. Right? So our job now is just to find what's the quadratic guy. Can find by long division or comparing coefficient.
Mr. Tan, I know you said that the 6.5 and challenging question for polynomials is I mean, don't know is okay, but could you still go through it?
Okay, can. 6.5, okay. Let me check. Where am I? Okay. 6.5, right? Or is it 6.4? 6.5,
Yes, 6.5.
6.5, okay. Wait. This yesterday's notes, sorry. Okay, 6.5, right? First, we need to factorize the expression completely, which is okay lah. I mean, so what we'll do is the first step, of course, we need to find the linear factor lah. Okay, we need to find a linear factor. Okay, so by default, we can find that x plus 3 is a linear factor. Okay, then by factor theorem, okay, we can see that our cubic guy is going to be equal to a linear guy multiplied by a quadratic guy. So this is our cubic, 3x squared minus 36x minus 81. Okay, this is cubic, this is linear, this is quadratic. So for the quadratic guy, I mean, you sort of can see that for me to get negative 81, it has to be negative 27 times positive 3 lah. That's why you see in the solution, I mean, teacher solution always got shortcut. So they just put 3 times minus 27. X cubed has to be a 2x cubed. That's how they get 2x cubed here. Then they compare coefficient, they got negative 3. So straight away, you have the quadratic guy out. You factorize further, you got the linear guy out. This is the finalized factorized form. Okay? So far, okay? Okay, okay, so then after that, we need to solve this equation. So this equation and this equation, actually no big deal, is the same because to factorize and solve is easy. So earlier on, we factorized this guy to look like that. So now we are just basically equating it to 0 since we are solving. Now by the zero product rule, right? So if we equate to 0, then either x is equals to 9/2 or x is equals to negative 3. Okay, so this is but just because zero product rule. If I take a multiplied by b equals to 0, this implies that a equals to 0 or b equals to 0. That's all. Okay, then after that, okay, so this part, right, okay, so Ashton, I check part 2, okay, ma?
Can.
Part 3 is the difficult one. Part 3 is it's like the main course, the finale is what makes this question so challenging. It is, but I mean, yeah, okay, so I cannot say anything. Okay, anyway, yeah, so this one, right, okay, you see, this, you need to relate this to this, right? Basically, is to replace x with something. So can I say that this looks like 2 of p power half to the 3 plus 3 p power half to the 2 power 2 minus 36 p power half to 1 minus 81 equals to 0. Now you see, okay. So actually you see, just look at this. Just look at this and you compare with, oh shucks. Just look at this and you compare with this. Just look at this and you compare with this. Just look at this and you compare with this. What does it look like to you?
X equals to P power half.
Correct. X equals to p power. So very simple. I go to the equation. I just replace my x with p power half. Right now. So earlier on, we know the equation looks like that. Right now. So we know the equation. So basically here, right, x equals to 9/2 or x equals to negative 3. Right? Very simple. Just replace the x with p power half. Replace the x with p power half. You get p equals to 9. Okay, so cannot, this one reject, sorry, I'm so stupid. Yeah, because square root p cannot be negative. This one, p will be equals to 81/4. And with that, we are done with the question. But this is the most difficult part. This is the most difficult part. Okay?
And what about a challenging question? Thank you, Mr. Tan. And a challenging question as well.
Okay, this one, right?
Yes.
Yeah, okay, let me think. Okay, first part is okay lah. So first part, you just do partial fraction as per normal. You do long division. Okay, so give me a second. Okay, so after you do long division already, right? You get this, right? Okay, you can do long division. Basically, you break down to partial fraction. Then this is the part. This is the part where I will do my partial fraction into the next portion. Okay. Don't care the carve out rule. Okay, so I mean just use comparing coefficient. Okay. After that, you solve already. Now the challenging part is part two. The challenging part is part two. So part one is basically normal long partial fraction, normal partial fraction. Okay, normal partial fraction. All right. After which, this is the part where it is not easy. So if I look at let me see. Let me see if I can break it. Okay. So now you see this part, right? Okay, you just observe this, huh? Hey, sorry. Does this looks like this guy? Do it look the same?
Yes.
Look the same, right? Look the same, right? Okay, so very simple. This is the case where, I mean, if x squared, if you sub x as 1, if you sub x as 1, right? Then this guy basically can be written as using this format, right? 1 plus 1 over 1 plus 1 over x plus 1. Can I say that?
Yes.
Can. Yeah lor. So then this is then yeah, so this portion can be written as this minus 2 plus 2 plus 2 plus 2 plus 2 over 2 2 plus 1 over 2 plus 1 over, sorry, 1 over 2 1 over 3 plus 3 plus 1 over 3 plus 1 over 4. Yeah, so it will look like this. Okay, so far okay.
Yes.
Okay, so it will actually cancel out. So then it goes like this, it will actually cancel out. So I group all the numbers together. Okay, see, I group all the numbers together. I group all the numbers together. Then you can see 1 minus 2 plus 3 minus 4 plus 9. Okay, so all these are basically just cancels out. Okay, so all these groups of this here, 1 minus 2 give you negative 1. 3 minus 4 give you negative 1. 99 minus 100 give you negative 1. There are basically 50 pairs of negative 1. Okay, there are basically 50 pairs on the keynote. Basically, just by looking at all these numbers, 2, 3, 4, 9, 100, all these numbers. Okay, now 1 over 1, 1 over 2, 1 over 3, 1 over 4, all here. They are all here, this part. So you can see that you have 1 over 1 plus 1 over 2, minus 1 over 2, plus 1 over 3. So actually, you see the pattern is here. There's 1 over 1, 1 over 2, minus 1 over 2, minus 1 over 3, plus 1 over 3. 1 over 4 minus 1 over 4 plus 1 over 5 minus 1 over 5. So all the in-between fractions, right, will cancel off. Everybody will cancel off. The only guy that you're left with is probably minus 101 and 1. That's why I'm left with this 1 minus 1 over 101.
Oh, okay, okay.
Hello.
Thank you, Mr. Tan.
So I combine together, then I find my final answer. Rather tough, okay? Rather tough.
Mr. Tan, one more question. Would you mind going over challenging question for the probability from like part two onwards?
Challenging, topic 7 notes, huh?
Yes, topic 7.
Topic 7 notes. This one.
Yes.
From part 2 onwards. Okay. So part 2, right? Okay, so this one, let's warm up into the question. So this is the one about Jerry giving character So the character, there are total of like 4 different animals, or each with 4 different color types lah. Okay, so sorry. So from here, okay, find the probability that both the items are horses, but neither of the item is orange. Both are horses, neither is orange. So what you want to do is very simple. You pick the item, right? You basically want to exclude the horses and you want to exclude orange. Okay, you want to exclude horses and you want to exclude orange. Okay, so if I look at this, right, you are interested in these three. These are the so-called not orange horse. These are horses but not orange. So the sample size of what you want, right, will be 7/56 for the first pick. 7/56 is for the first pick. 6/55 for the second pick. That is what you want. Is that okay?
Yes.
Because you got seven, or you only got 7 choices for what you want. You only got 7 choices. Remember that. Okay. So with that, yeah, the answer is just 7/7. Yeah, over here. Eight. Sorry. 3 plus, sorry. 3 plus 4. Oh, my math. 8. 7. 1 plus 3 plus 4 is 8. Not 7. Okay. 8. 8/56 times 7/55.
Can.
Can. Okay, so the answer you should get for part 2A to be 1/55. I'm guessing you're copying or then pause a while.
Mr. Tan,
Yeah.
can you go through question 12D for a revision package, topic 5 and 6?
Okay, you just give me a while. I will go through
Okay.
question 12D of topic 5 revision package. Okay. Okay. So after that, okay, actually I go to the next one. B, part 2B. Are you ready?
Yeah, can.
Okay, part 2B. Okay, part 2B. Okay, basically we want the probability where the two items, right, include exactly one dog and exactly one item that is yellow. Okay, so how will it go is like this. Okay, basically one dog, one yellow, right? The thing is, if you notice, right, there is a possibility where if I choose the yellow dog, right, then in one item, right, I will have fulfilled both conditions. In one item, I will have fulfilled both conditions. So it's also possible that I may need 2 items to fulfill the 2 conditions. So one possibility is my first one can be a yellow dog straight away. That means my first item, I already hit both my targets. But my second item, right, is cannot hit anything. No dog, no yellow. Then that is how I meet the overall condition of one dog, one yellow in my 2 items. So what do I do next is then I will count. Okay, so first one, yellow dog, right? There are 7 yellow dogs out of 56. Okay. The next one cannot be dog, cannot be yellow. So basically, the next one cannot be dog, cannot be yellow. So I must take away all the dog, I must take away all the yellow. These are the only ones I can take. Okay. That's the idea.
Okay.
Is it okay?
Yep. Thank you, Mr. Tan.
Okay. So then after that, okay, do you need a copy? So I pause a while.
Okay, done. Thank you, Mr. Tan.
Okay. Still got one part. Okay. The one part is like this. Okay. So for the one part, the last part is like the M over 56 times. What do they mean? Is okay. Now I will see the items, right? As okay, so I will see the items as 16 possible outcomes, 16 possible color character combi. In this 16 possible color character combi, okay, I have these 16 combis, right? Okay, so the possibility or probability of choosing these two at random from the 56 is 1 over 57. What do I mean? Total, there are 56 items here, right? One of them, I'm going to pick the first one. Let's call it M. There are M items. But M is any of these numbers. 1, 2, 3, 4, any of these numbers. Okay. Then M out of 56, right? The second item, I pick another one. It must be different. It must be different, right? Because they say choose these two. Then I multiply by 2 because it can be M followed by N or N followed by, there's an order. I may be choosing M followed by N or N followed by M. This, right, multiplied is giving me 1 over 77. Okay, M will basically be any of the items here, any of the items here, any of the items here. Right now, so there's a possibility of M. So this gives me 1 over 77. Okay, so once you form this equation, right, you will find that if I solve this, I will get overall, if I equate this to 1 over 77, you are going to get Mn equals to 20. Okay, you are going to get Mn equals to 20. So far, okay?
Yes.
So if Mn equals to 20, what are the possibilities? That means, right, could be 4 times 5. So one possibility could be something like this. It could be this one, 4 times 5. Orange bird, yellow bird. Could be white horse, white rider. Right? So there are total of 1, 2, 3, 4. 4 combination.
Oh, okay. Okay.
Okay,
Thank you, Mr. Tan. Can.
okay, next one. Okay, do you need a copy? I pause a while. Don't worry, I pause a while, copy first.
And thank you, Mr. Tan.
Okay, next one. It's question 12D of question 12D of topic 5-6, is it? Topic 5-6.
Yes.
Okay. So question 12D, 12D, this one.
Yeah, that one.
Okay, this one actually is a scam. Actually, it's a scam. So what I want to share with you actually, right, is this question here. It was also mentioned earlier in the previous video. This guy, right, can I say that this is the same as log x to the power of -1?
Yes.
Can I therefore say that it's just negative log x?
So it's -1.
Correct. So I'm actually just getting the equation of log 2 plus x less than equals to -1. Right? Such a beautiful question. So, so from here, again, okay. So from here, I divide both sides by -half, -2, right? Dividing it changes the inequality sign. So I have log half. Okay? Can all? Then change from index form to logarithmic form. This is the same as 2 to the power half. X is more than equals 2 to the power half minus 2. And we are done.
Oh, that's it.
That's it. Easy peasy
Oh.
then. Very chill one. Yeah.
But the answer key says something else. It says x is more than 0 and
Oh shit, I think I
x is
know.
not equal to 1.
Okay, I think it's because. Oh, okay. Here, x is cannot be 0. X cannot be equals to 1 because x has a base. So sorry, I missed this out.
Oh, yeah.
So this was another condition to consider. Okay, so if you take the intersection, I think it will just be this answer.
Okay, Mr. Tan. Thank you.
Okay. So done. Okay, so I saw one from Maggie. Revision package topic 8, question 6, part 3. Okay, topic 8, question 6, part 3. Topic 8, question 6, part 3. Topic 8. This one. This question is the same as your challenging question. Okay, this question is the same as challenging. Okay, so Maddie, I asked, part 1, part 2 you can do, right? My guess?
Yeah, can.
Can, huh? It's actually a challenging question. Okay, so I believe, wait, just 1 second. Let me just copy the answer. I believe your answer is this one. Okay, it's actually the challenging question in the notes. Okay, so part 2 you do already, right? Okay, so actually for part 3 to part 2, very simple. You just replace x with square root p. That's all. You just replace x with square root p. So once I show you, I think you can see already.
Yeah, I replaced it with square root p already.
Then you should get the answer here.
But like, I don't understand why did they reject the another answer.
Because square root cannot be negative. Square root cannot be negative.
Oh, okay, can.
Correct.
Yeah, okay.
Okay. Yeah, because square root cannot be negative. So I think you have something like square root p equals to negative number. So that one cannot.
Okay, can, thanks.
Okay. Jolene. Oh, your time prep sheet. I don't have the time prep. Today you got picture or not? I haven't got my computer. Haven't I open?
I have.
You send me a photo. Let me see. I haven't. Why you so fast at time prep? I haven't received. I haven't read the time prep yet. Wait. I'm not like this. And time prep. Oh, you send me already. Okay, thank you. Time prep question 10. Oh, the photo so small. Okay. Oh, my eyes. Okay. This one, huh? Jolene, this one,
Yeah,
huh?
that one.
Okay. What's bothering you for this question? Let me see.
Because I
Look at
saw
here,
like they gave us the equation, then they say exactly 1 root if k equals 0. Do I sub in k equals 0?
Let me see. Okay. Oh, okay. You never have. Okay. Part B, is it? Part B, huh? Part A. Yeah, exactly 1 root if k is equals to 0. Your k, if it's equals to 0, yes, you just sub k equals to 0. That's all. Then you show that the discriminant equals to 0. So very simple. All you need to do, right? You sub k equals to 0. Then you show that the discriminant equals to 0. So
Oh, okay.
if you sub, wait, cannot, you sub k equals, wait.
If
Because,
k equals 0, then you'll become x plus 2.
yeah, then you have x plus 2, right? Then it's just x equals to negative 2. One answer, lor. It's just one
Yeah.
answer. Yeah, that's one answer. Yeah, that's all. Don't even need discriminant. Yeah, 丢偏, bluff me, cheat my feeling. With that, okay, ma? The rest of the question, okay, ma?
For B, right? Do I solve the equation? Then after that I sketch the graph.
I solve the equation and then I check the graph. No need to solve because you can't solve. What you do is you sketch the graph first. So this one, right? You sketch y equals to ln x and you sketch y equals to x minus 2 because this equation is the same as ln x equals to x minus 2. So ln x looks like that. Okay, this is y equals to ln x. Okay, sorry, I never draw very well. Like that, y equals to ln x. Then I believe x minus 2 will cut at 2 points. Y equals to x minus 2, right? The first point is 3.146. The second point is 0.159. So from here, right, you see ln x, x minus 2, right? Now you are basically looking at where you want ln x to be below x minus 2. You want the blue color graph to be underneath the green color graph. Where is the blue color graph going to be underneath the green color graph? It is basically this region where x is more than 3.146. Over here, where x is less than 0.159. That's what it looks like. Is that okay?
Oh, okay, thank you.
Okay. I go toilet very fast.
这蛋got insane share, bro. What the hell?
Any questions so far? On your video lah. Then I got people to chit chat with. Yeah, Ethan, you got a question?
Yeah, for the
Hmm.
topic 7 revision package probability.
Question 4.
No, question. Oh yeah, question 4.
Okay. So this question was also mentioned yesterday. I think the one video happened that just now I also just went through. Okay, so let me find it. Where is it? Wait. I suddenly lost. Okay, so this one, okay. Here, okay. Basically, the idea is that, okay, so I throw two sandbags, so I throw two sandbags, okay. So imagine that I throw sandbag and it has to land either, it can only be a few scenarios, either both land inside here. Now, if both land in X, right, I will win a big soft toy, okay, because I'm very accurate. But if one land in X, if one land in X and one land in Y, then this one gives me a small soft toy, okay. So what is A union B, right? A union B prime. A union B prime basically means that is the opposite of winning big and winning small. What does it mean? What's the opposite of winning a big toy and winning a soft toy? The opposite will basically be I'm loser. I go back home empty-handed. Okay, I go back home without any soft toy. So for that to happen, right, it means that either your A union B has to be, your A union B prime is YY. Both land inside the big circle. Both land in the donut. Right? So if both land in the donut, right, that will mean that you're landing the first in Y and the second in Y. First in Y, second in Y, that will give you 9/16. So 9/16, where A union B prime is just basically the first landing in Y, the second also landing in Y. Is that okay for you?
Yeah.
So the fact is both properties are actually the same. So without further ado, right, the probability of Y actually is just the square root of 9/16 because it's like 3/4 times 3/4. Right now, we are going down this route. This is my A union B prime. This is my A union B prime, right? Where we are going down this route. Okay, so for that, once you have 3/4, 3/4, you will know that this is 1/4, this is 1/4, this is 3/4, 1/4, because they all add up to 1. Is that okay?
Yeah.
Yeah. So from there, then you should be able to do part 1. Okay. So you should have your tree diagram drawn out for you. Let me know if okay. Then from part 1, you should be able to do part 2. If you don't know part 2, then you let me know. And then I'll talk a bit more.
Mr. Dunn, could you go and go through partial fractions like question 6.3 again?
6.3 again. Okay. Okay. So 6.3, right? Okay, first of all, I must first check that okay, it's a proper fraction. On top is power 1, below is power 3. Right? Power 1, power 3. So this is a proper fraction. Okay. After which I will split it using my memory work into the two linear forms. Is that okay with you?
Yeah.
Okay. After that, I combine into one fraction. Yeah, whether I combine the one fraction or common denominator. So then I will equate my left to my right. So then this part is just like topic 8, part 1. I'm just comparing the coefficients. Okay, so from here, I can substitute x equals to -2 I can compare coefficient of x squared. Okay, I can get my ABCs out. So once I get my ABCs out, right? So you can see I get my A, my B, my C, right? Then I can form my partial fraction. Settle already. Yeah. Very easy, very easy.
Oh, okay.
But it's not as difficult as you think. In case you're frightened, it's very
Yeah, because like originally I saw it and like, yeah.
Okay, Maddie, yes, can I help you?
Can you go through revision package topic, the probability, but question 7 BII?
Question 7 BII.
Like I got the answer, but the inequality sign is wrong. And also I want to ask in inequality, like, are you allowed to like change to log form?
Yes, you can change to log form.
But then I change to log form, the inequality sign is like kind of weird.
Okay, such that the outcome of the outcome is incorrect for at least one of the components. Which one? Let me see. What's the answer? What's the answer for B part 1?
1 minus 0.941 to the power of n.
1 minus 0.9. This is correct? This is
Yeah, that's correct.
Okay. Then after that, for at least one of the components exceeds 0.6. That means I want this one to be more than 0.6. Am I right?
Yeah.
Then 1 minus 0.6 is more than 0.941 to the power of n. 0.4 is 0.941 to the power of n. Take ln on both sides. Whether ln or log, it doesn't matter. So I ln 0.941 to the power of n. Ln 0.4, I divide by ln 0.941. That is a number. This will become less than n. The reason because this one is negative. This is negative. When it's less than 1, right? Ln of less than 1 is negative. So this will be your answer already. Ding! Come on.
Can I like for the third step, can I see it as an equation and just like convert to log form?
Can. For the third step, you can do that. Just be careful because you don't know what n is. If n is less than 1, then inequality sign must switch. Yeah, my advice is 不要. My advice is take log on both sides.
Okay, can.
Thank you.
Mr. Tan, but for just now that revision package question 4, right? How you know that is 1 quarter and 3 quarter? Is it because you immediately from that side you can just square root and get 3 quarter and 1 quarter?
So after the 1 quarter, 3 quarter, because they must add up to 1 in each branch, right? They must add up to
so is you find it first, then after you draw the tree diagram.
Yeah. So I know y and y is 3 quarter, right?
Okay.
So I know that x is 1 quarter. Okay, lah. If there are no questions, I will stop here. Okay. I'll be online again tomorrow, 8 o'clock. So any questions can also wait until then can ask me. Okay? Okay, see you all.
Thank you, Mr. Tan.
Bye-bye.
Okay, Mr. Tan.
Bye.